Hello and welcome to this lecture on our attributes and attribute nodes. We are going to look at in this lecture the comparison operator, and I've had a cup of tea since our last lecture, so hopefully my voice will hold out. But we're going to get started by essentially jumping up here to nodal and base, right-clicking on base, and we're going to go new Python file. We're going to call this attribute condition. Yeah, I'll keep it as attribute condition. Within my system, essentially, I've split the functionality out into the utils, but I've also split these sections out into their comparison operators, arithmetic operators, and core functionality with identity operators also in with them. So kind of how we're splitting these tutorials, but it just, again, it makes it very easy for me because I'm looking at, again, attribute operators, attribute comparison, attribute identity operators, comparison operators, and arithmetic operators. So again, it's very easy for me to locate where the problem is, but I mean, you can also do that very easily by having them all in one file, which for the ease of this lecture, we're going to do essentially. But okay, we've got our condition, well, our attribute condition, because what we need to do is when the dunder methods are called for the comparison operators within attribute, or within our attribute class. So if we just minimize here, we want to be able to then essentially use another class which will hold our condition node or our condition information and be able to set, plug in, and do all of the, again, all of the logic that we need to do to make our comparison operators work. We don't want to, again, these are quite big functions, so we need to make sure we split this out. But otherwise, yeah, we'll just get started now and yeah, strap in and we will have a look and see how it goes. So let's start by taking our docstring over. What we will do, we'll just take the docstring. So start with the docstring. Okay, we're going to say that, well, this is just condition node functionality. Perfect. And what we're going to do is from modules.nodal, we're going to import dep. Okay, and now we're going to make our class. I'm going to call that, surprise, surprise, condition. Yeah, we want that to be as obvious as possible because it is just making condition nodes. Okay, we have now inherited all of our dep node information. I could always spell condition, right? That would be good. I don't know what it is, but even though there's no one literally, I know people are going to, at least one person's going to listen to this. So I'm going to make a few of my friends do it. But I am terrible at public speaking. And even when it turns out not in public, that is tragic. I don't know, you might see my history. I used to ice skate as a kid, and like I used to love dancing. I could literally just switch off from the world, but people used to watch me doing that. And I could literally switch off and I would be absolutely fine doing that. But the second I have to do something like talking in public, I am terrible. I am much better at just switching off and getting on with work. Not having to think about anything external. So, all right, this is the class that will carry our condition, again, tragic, node information. I think it's called type fright. I don't know if that's just a phrase that I coined a while back, but definitely a thing. All right, let's create our initiate function. Okay, so we've got all of our arguments here. We've got our node, which is being passed. We've got the first term of our condition node, which again, I should probably explain a bit more. Let me open up Maya and then I'll talk through a little bit about condition nodes if you do not know about them. These are actually going to need to be keyword because these might not be set or be being set every time. So I'll pass up there as none. And what we're going to do now is just make sure that we initiate. God, that tea didn't last long, did it? We are going to initiate the dep node within this function, and also pass through to it our node and the term condition, so that we actually, oh my lord, we actually create the condition with our node. So now, if we remember rightly, within our dep node, if you pass a dep node, a node, and a node type, it will go ahead and create that node type. That is what we are essentially inheriting within our condition. But now we can add a little bit more functionality. So we've got our terms. Let's Control Shift and Alt. Select these 3 items. Press Control V to put them all. And so now another fun thing I can show you is that if you put your cursor here and you double tap Control, and then you press down, you will see that we get multiple cursors, and that's just very useful in times like this, where we're going to go essentially if these conditions, or sorry, if these arguments exist, or if they are Boolean true, we will again give ourselves some functionality. I'm going to highlight each one of those, Control Shift and U, and then we will open up parentheses and we will add that information through. We will now press, go back to the beginning of the if, okay, press enter, and we will write a little bit of a docstring. Okay, perfect. So, as we were saying a minute ago, creating our dep node, we've inherited it. We are now running the initiate of the dep node. We are passing it node and condition. So it will use the node that has been passed to create a condition. Okay, the node is essentially just a variable that we're going to pass through to it. So it can be, it could be just the name of the current node that we're working on, but that wouldn't be brilliant. So we're going to be passing through to it a brand new name, or the node name that we're going to work with here. Okay, and now let's create our functions down here. So Control Shift Alt, Control copy, tab in, and then press, actually, sorry, we'll do this, go to the beginning, and now double tap Control, and then press down with the arrow keys, and then press diff, open up self, and then for the minute we'll just put pass in each one of these, so we don't get the red. But okay. Each one of these, oh, actually, so let's again click into each one of these, Control Shift Alt, press comma, and then Control V again, because all these are going to take an argument. And actually, we don't need that. That is not something we do need. So what we will actually do is we will use a little bit of our magic already that we can use to set the operation. So actually, sorry, let's open up our Maya, and what we're going to do is we're going to open up, sorry, within Windows, the node editor, and what we're going to do is click in the window, press tab, and then type condition, and then just hit enter, and we have a condition node. So this is essentially what we are creating within our Python class. Now press 3 to expand out the node. And let's have a little look at what we get over here in the channel box. So first we have first term, second term, and then we have if true and if false. So these are all the inputs essentially. Well, the inputs it gives us, these aren't all the inputs, but if we double click, what we do is we now open up the condition node within the attribute editor, which gives us a little bit more information. So we've also got operation here, which you'll see is, well, similar to Python in that we have our comparison operators equal, not equal, greater than, greater or equal, less than, or less than equal. So all of the functions that we need from Python are actually replicated within this node. And then we have the XYZ parameters here and the first term and second term. So obviously if we had 1 here, and this was set to equal, these terms are not equal, so you would get false, the false parameter output. And if it was set to 1 and 1, then you would get equal, so you would get if true. And all of that output comes through here, the out color, which is either a parent, a little parent output, or the children outputs here. Okay, so that is our condition node, essentially. And again, you click up in these little bars over here to expand out the window. That's the same as doing 1, 2, 3. So 1, 2, 3 opens it up. Okay, but we've got all of our places to plug into here. So now we're going to essentially use these. But what we're going to do is we're going to use our magic here. We're going to go self.attribute.set. And then we are going to put in the operation that we have passed through up here. So if there is an operation, or actually this should be if operation is not none, maybe, because let me just have a look here. Let's go back to our Maya window. So if we set not equal and then equal, let's have a little look in our script editor. Let's go to layouts, saved layouts and script editor perspective. Let's see what we've got here. So we've got operation is 0. Okay, so equal is 0, not equal is 1, 2, so that's probably tiny. Okay, here we go. So we've got 1 and 2, and then if we set that to the third, so we're looking at indexes here. So we've got 0, 1, 2, and 3. Okay, so what we want to do is we want to try and mimic that behavior. So set this, excuse me, the default is set to equal. So essentially, if we have anything from 1, 2, 3, 4, or 5, we want to be able to set that. So if operation is 0, we actually don't really care because it's already at 0 as default if we're creating this node. So we will just leave that. But again, you might have to be tempted to go if not none, for example, which is obviously the default. And then if it was 0, we'd set it to 0, 1, or anything. But it doesn't really matter because if it is none, it means it's essentially 0 because 0 comes through as false as well. So if that was 0 or none or false, essentially this wouldn't be enacted. So it doesn't matter because we're not changing it. But if the operation is passing through a 1, then we will set the operation to 1, 2, 3, 4, 5 respectively, whatever is needed. But let's have a look. We've now got the only things we really need to do here then are first term and second term when we're creating the node anyway. We're going to set a completely different function for setting the condition. So we're going to go def set condition, and we're essentially going to put self in and have 2 keyword arguments, which are if true. What am I saying? Sorry. That is actually if true equals none, and if false. And they're both going to be equal to none as default. Okay, kind of mimicking again the functionality. Now, I'm going to do this as set condition node just in this tutorial to keep everything logical. But again, to keep parity with what we're doing with our attribute node, like with set, get, all of these Python kind of consistencies, if you're comfortable, I would just call this set. But at the minute, just for, again, ease during this tutorial, we're going to call it set condition, just to be obvious where we are. But okay, this is our condition node. Okay, beautiful. It's literally just, again, a class that creates a node and in a very nice Pythonic way. So let's say you want a ramp node because you're doing a sticky lib setup and you want the ramp to control everything. Then you would just create, again, something called ramp, type in condition, type in our ramp, and you have a ramp node. I mean, it's just that beautiful. That is what you've got to love about Python. When it's written nicely, you can start abstracting complexities very easily, and it becomes incredibly readable. Like, you may have not understood what this meant before, these sets of tutorials or my tutorials before at all, and that's great. That would literally make me happy. So please contact me and say that if so. You might have been so frustrated with my speaking that you're hardly making it past this point here, which again, I'm so sorry about. But if I'm just trying to share my knowledge here, I'm not a very well-spoken individual, and even worse when I'm having to do something a bit technical and type and think about everything that's going on forward. So I'll just apologize in advance to that. But anyway, let's get back. I digress. Let us first go to set condition term. What are we going to do? Let's go to our first setup, and we're going to write the doc string for what we're going to do here, the first set first term. And actually, we have 2 that are the same, so we might actually just copy a bit of functionality over with these. Okay, perfect. So again, we've abstracted a little bit of complexity again. What we're going to do here is pass through the information from first term, second term, and then give the name of the attribute that we're going to set, first term or second term. All right, let's jump forward, and now let's make our new, see, just give us the option to do it. Add method, set condition to class condition. Yes, brilliant. There we go. Okay, and what we want to do is we want to, instead of calling this second term, because that's kind of inferencing or saying that we're just going to essentially use this, we're going to call this value. Let's move this up a little bit as well. So highlight, press Control Shift, and then jump it up. So press up arrow, and then that'll move it up past this lower method. Okay, so we've got value and param. Oh, sorry, we don't want that as param, we want that as term, don't we? So this will be first term or second term, so we want that to be term. This will be the value that we are passing through to it. Okay, perfect. So let's have a look at what we have here. We've got essentially three cases that we're going to work with. We're going to first work with the idea that we pass through to the condition node. So let's jump back to Maya. That we pass through the first term or second term, that we pass through an integer. So somebody just passes through a number 2. You could just say that that will be either number 2 or 1.7. Let's say you have a maximum number that you want something to stretch to, but then before it then stops stretching, they might just pass through that number and set that. So within the term that has been passed, the first or second term, see we're using our node.attribute, and then we're going to again use our smart terminology here because we're not sure what it's going to be. So we're using the index get get item. But what we want to do is essentially use it flexibly. So that's why we've got the open brackets, because that allows us to kind of set it dynamically or with a nice bit of flexibility. And then we're just going to go set to the value. So that's the first instance that we just pass through a float or an int. But the second instance is that we pass through essentially a value with children. Okay. So the attribute essentially that we're passing through to it is a class-based attribute with children. And then we are saying, well, if it is an attribute and it has children, then what we're going to do is we're going to use it this way. We're going to get each one of the X, the Y, and the Z attributes, split those out from the value of the children. So from the value children, because again, this is essentially a node that we've just checked. We've just found out that this is essentially a node. So this could be, say, this could be sphere.a.s. So it could be a scale, and it could be the parent. So it has X, Y, Z scale below it. And we're going to split that out into these individual attributes. And what we're going to do is we're going to use a little bit of logic here, which we haven't done our multiplication yet within our attribute class. But what we're going to do is we're going to add all those items together, and we're going to say that those are the addition node of those. The output of that is going to be plugged into self.attribute term. So within the term that we are looking for here. So we're not just setting it to a value now, we're actually plugging it in to be whatever the output of these items are. It's a nice little bit of flexible way. You could essentially say, well, if the overall, let's say, scale of a ball is over the combined amount of these, then don't scale anymore. We don't want it to scale more than 2-3 times the size of the ball, for example. And then what we're going to do is we're going to return, because we've used a parent atta, we're going to return the parent. Okay, perfect. And now the third case, so the third scenario that we're going to work with is that essentially that value we're just going to say is an individual attribute value, and we are just going to plug that straight into term. So nice and easy, go straight in this way. But we are doing it this way because we actually already know that this is an attribute. We know that self is a dep node item and it has access to the A. So, and we're now setting the term. But if this is a string, what we won't be able to do is start off with this one. So we couldn't write this way around. Because if value was just a string, then it doesn't have the ability to use this right shift, this right shift essentially into this item. So it would just fail. But we know that our nodal items do. So that's why we're using the left shift. So another kind of a case scenario for using that. So Perfect. And what we've got here is then, for these first two scenarios, we want to then default return self out color R. So we'll just return the color R, which again, if we look at our node, is essentially this child attribute. Because if we've done all of our logic, we're essentially just plugging them into R, the true, the false, the first term, and then we're going to just plug them in and then get the output. But if we've got a parent attr, we're going to actually give back the parent that way. There are other ways, which I'll show you later on in our testing examples, which this will work, where you can just plug in everything to true, false, true or false RGB to each one of the inputs. But at the minute, we're not going to worry about that. Brilliant. So there we go. We've got our initiate function. We've got our first term function, which sets the first term. We've got our second term function, which sets the second term. And those are being then all both plugging into the set condition term, which again handles both with all scenarios. And now we're going to set condition. So we've essentially set the terms, but now we actually want to be able to set the condition. So if we're looking, we've set these two terms. We've set the operation in the initiate, but now we want to be able to set the if true and if false, which we can look at down here. Now, I'll also put some examples in here, actually, because otherwise it will be a little bit confusing to look at. Okay, there we go. Now, this is quite a long doc string, but I hope it makes clarity, or it gives clarity to what we're doing here. And so, what have we got? We've got set to the value of true and false in the nodes, or I should say in the node, and the condition node even there. Might as well just put that again, even though it should really be inferred. Either use an int, float, list, tuple, or string. For example, scale x or scale, or just sx. Should put that in maybe. There we go, or sx. So these will all work. Let's highlight them as well. And here we go. Let's have a look at the arc. So we've got if true, and these are all the parameters it takes, which feels messy, but it will make more sense in a minute. Let's just call this attribute object, actually, just because, again, we shouldn't really abbreviate. Clarity, it'll make life easier for us in the future. But again, quite easy. The value to use, they're quite straightforward. Now, this returns the class attr. So this returns either the parent or the child attr to work with, depending on what you've plugged in. If you've plugged in a parent, like if you plugged in a scale, even whether it's an attribute, a class-based attribute or not, if you plugged in scale or scale x, it will then treat that accordingly and return you either the parent or the child, assuming that you want to work with the parent going forward and no child. But even then, you could still just append your code quite easily just to work with its child instead. Let's go with example one. So as you've seen in the write-up of these docs, what we've got here, let's say with node 1 and node 2. Node 1, we want to say, well, if node 1 scale x is less than or equal to node 2 scale x, okay, then create a condition for that. These are basically the parameters. So we are going to plug this into the first term and this into the second term. We are then going to say, well, the operation is this integer, which we will set in our attribute class in a minute. But this will be essentially what sets each one, with what we use to set this parameter. And then we are going to be able to go through, use this and say set condition, if true, use node 1, use node 1 scale x, but if false, use node 2 scale x. And I know this might seem a little bit crazy, but if the reason you bought this course is because you're a little bit more advanced with your status within Visual Effects, you'll understand how useful and how cool this line is, because this abstracts about 40-50 lines of code and makes everything more readable. If you've literally just got this to look at, this is hugely more readable than 20 lines of code making the node, setting the node, and doing all of that, whereas this just does all that for you behind the scenes. So that's great. And then node example 2, we've got the same initial beginning with set condition, and then we're going to set to true to 1 and to 0 to if false 0. And then we're also going to plug it in and connect it to the output, which is scale x. Example 3, another way of using this, we're just going to, again, pass everything and give it as a calculation node. So this will now be our output parent or child attr. So this will be condition node dot a dot output color r. or color, depending on if this is a parent or child. And then you can say, well, the calculation node set, don't really need that. Calculation node set condition, if true, 1, 2, 3, 4, or 1, 2, 3, and then if false, 10, 3, 4. Again, just random numbers. But then we can plug it into. Oh, that is weird. Why are you not letting me highlight that bit? Ugh, madness. Okay. And then it will plug into node 1 attribute, and I don't know why I put that there. That must have been a mistake. We will just plug it into scale Z again, just for consistency with above. Okay, so this is how we want this to all work. Let's go ahead and write the code now. And then that is our condition node set up. We just have to set up the operators within our attribute class that point to this awesome little condition. Okay, brilliant. So we have our code. Now, what we're going to do here is we're going to say the default, we're not going to return a whole kind of, or the parent attribute. So probably should say return parent. Actually, let's refactor this. Let's go right click, refactor, rename. And what we're going to do is we're just going to say parent. And so what we're trying to look for there is we're going to say, well, are we going to return the parent node or the child node? And we want to be able to kind of go through this and say, well, logically, what are we getting? So we've got, we're being passed, are we being passed an init float, or are we being passed a child or a parent node to plug into? Which if we are being passed a child, then we would just return the child attribute of outColor. So we'll return outColor R. If not, we'll return the parent of outColor R, which is outColor. And so that works quite logically. But we also actually want to maybe have the ability to be able to set that. So let's put that up here and go return parent. And now what we are going to do, it should say that this is missing in the docstring. Yes, perfect. So we're going to say add docstring, see if it puts it in the right place. No, it doesn't. Again, we'll talk about this later on, but it's set to the wrong docstring parameter, which we can change in settings, but we won't do that right now. So I'll just go here and go return parent, which accepts a Boolean. Whether we return a parent or child attribute. Okay, perfect. So we've extracted a little bit of information from our script again, put it into a parameter, which gives us the ability to kind of set it here. And what we're going to do is, although we will be setting it as default, what we are going to look at is, okay, looping through the if color true, if color false. So what we've got is if true, whatever's been passed, whether that's a list, whether it's a tuple, okay, an attr, an int, a float. We're going to start checking through them now, because if true, that's what we've passed. We want to then be able to plug it into all the sections of if true. So let's have a little look. So we're at if true, and if we go through, and if there is not an attr, and I think essentially I've got that wrong. So value. So we want to be cycling through the value, but actually what we will do then is get the problem if we're setting something to 0. So I'm actually going to remove this because that's incorrect. And what we are going to do is, though, we're going to check, well, we're going to see what our value is. And is that a float or an int? And if it is, we are then going to say, well, use this node and then set the attribute of the attribute color true or color false to with plus R, so the child attribute of this, so R. And as we've seen in our condition, we've got the R here for the children attributes. So if false, if true with the R, or just if false essentially. I should actually zoom in on that. Sorry if it's not big enough for you. Let's have a little look. Let's try to zoom in a bit. Yeah, so there we go. So we've got our RGB, got our parent, and the 3 children below it. Okay, and then that will just set the R value. Okay, and that will loop through again with everything that is within our option here. But now, if it's a list or a tuple, okay, what we're going to actually do is unlock these, and we're going to actually plug them all in to our attr, and we're going to cycle through it and then go self.a.attr set, which now we are essentially saying, well, set this parent node to being all of these values, which are now being packaged up, if you see the star here, and passed through as arg. So these 3 items then will be unwrapped and plugged into the parent attr, into the RGB. Okay, then we're returning parent, true. So we're actually saying return parent now, true, perfect, because we've input a parent, so we should actually want to input a parent. And okay, well, let's see. Now we've got else. So the last case now we're going through. Now we want to jump through the else, and we've got 2 conditions, or we've got 2 if statement, and we've got an if statement within the, so now we're jumping through to the else. And our first part of our if statement is saying, well, if the value class name equals attribute, if what we're dealing with is an attribute, and the attribute essentially has children, if it's a parent attribute, then plug the parent attribute in right here. Okay, so perfect. So we'll then find out it's a parent attribute, and and that will be plugged into the parent attribute of if color. Okay, return parent, true. So we're making sure we return parent again. Okay, then if it is not though, so if it's not an attribute, what we are going to do is then go for a last ditch attempt, imagining that this is just a string. We're just going to plug that into attr plus r. So essentially meaning that we can just use this string as itself and then output that. Perfect. So, and then we've essentially, assuming that our value is now a child attribute, it's the last kind of point. It's a child attribute, and we will plug that straight into our child of whether it's if true or if false. And then we will return back the fact that at that point it is a child. So we'll return back the out color R, but we will go through otherwise and return the parent, which is out color. So we've got a little bit of crazy logic here, but it does work. So, and if not, we're going to actually test it and then fix that. So we'll have a look later on the test. But okay, this is everything that we need to do now within our condition node. And we could actually put in a few little doc strings for this. So let's do that. Let's put in first doc string. Okay, perfect. So we've set a few comments in just to make sure it's clear. We've got connect the value attr into the new code. Okay, this is what we're going to do through this new section. And then we're first in the first part of our if statement, we are setting an integer or float. Second part, we are setting lists or tuples. And third part, we are going to connect either a parent or a child attribute. Simple as that. And then return back whether it's a parent or not. Okay, perfect. But let's jump back to our attribute base now. Okay, and what we're going to do up above, we're going to jump back. So we're jumping back into our attribute base. And what we're going to now do is below our dunder methods for left shift and right shift, we are going to start looking at adding our dunder methods for our comparison operators. So let's have a look at our comparison dunder methods, or whatever you'd like to call them. And there's going to be a little bit that we have to do of trickery right here. Because one thing we can't do to make sure we don't get circular dependency is we cannot actually import our condition node. Because our condition is importing dep node, we cannot now import our condition node straight into our attribute base. And that is because our attribute base is in some areas, our condition node is importing our dep node. We can't now import our condition node into our attribute node because our dep node is importing the attribute. So if we imported attributes, which then imported condition, and then condition imports dep would then re-import attributes, which attributes would then import, you'd end up getting that circular dependency going on, which would just crash Maya essentially, or give us some unexpected behavior. So what we're going to do is we're going to have to put in the import for condition essentially right within the function. But anyway, let's scroll down and let's get to work on that. So our first, let's actually just write out our operators. So we've got def, we're going to have double underscore, and we're going to go EQ. If you remember, that works with, that's essentially standing for equal. So we've got another 5 of these. Let's add these all in. Okay, here we go. Let's press Control-Shift-Alt to select each one of these. Or actually, let's do it the other way we showed you before. So double hit Control and press down with your arrow to multiply our cursors. We'll just press pass at the minute. Sorry, we'll go to the end of pass and we'll press enter so we don't get all our squiggly lines. Okay, and these are all of our equality operators, or our comparison operators. So we've got our equality operator here, which is equals. Then got not equals, greater than or equal, less than, or less than and equal. And what we are essentially going to do with these is put in all the functionality that we need to access that condition node in the way that we want. So that we'll put an example in here. Let's write a docstring and give ourselves a nice example for how we're going to call that condition node. Okay, here we go. I've copied some of this from our attribute condition. But what we're going to do here is we're making a condition node and setting the first and second terms. So what am I doing? Lord, there we go. Sorry, that's what happens when it gets late. So we're setting the first and second terms and the operation. Let's put that down there. Okay, example 1. So we're using our equality operator here. And what we're going to do is, essentially, we'll be able to go node 1 attribute scale x equals, or is equal to node 2 a, and then whatever attribute you want. So this can be a new attribute that you've added. This can be just an attribute that already exists. But what that will then do is this will build the condition node and plug these two into the first and second term. And it will use the equals operator or the comparison operator here of equality to check if they are equal. And it will return you the node, which then after you can set the conditions or the outputs essentially from that. So let's write that bit of code next. So here we are. We are importing our condition node to work with just within essentially this function. We don't want to import it at the base level because then we'll get a circular issue, or a circular dependency. So what we're doing is we're getting the name, which we will set to be the value node name if the instance of value is type self. So if we are, and else if it's not of instance type self, then we will essentially get the node name plus the string of value. So we'll either use the value node name or the value node name, or sorry, self node name plus string value. Okay, but we're actually going to need this for every other one of these comparison operators. So let's go ahead and make this into a separate class. Put this at the beginning because it's pretty much required. And we will essentially use a little single underscore to denote that we're only going to be using this condition, this function internally. We'll pass it through value. And then we will return a little bit of code. And all we then have to do is go self. And we are now calling our node up here. It's got one usage, so it's hooked up. And we can use this now in every other one of our setups, in each one of our comparison operators. Okay, perfect. Now let's have a little look at what else is happening here. Sorry, so we're setting the name, we've talked about that. And now the node name that we're going to get, we've got the condition name, but we want to actually expand on that. We want to actually use that as the first part. And then what we want to do is on the second part, we actually want to use the attr that we're plugging into, self.attr that we're plugging from. So this gives us a kind of a nice clear way of saying, well, this is what the condition name is. This is what is being plugged into. This is an equality operator and it's a condition node, CD, condition. Okay, they should all be, again, have nice consistent naming. Every node you should have within your system should be named in the same way. I would suggest maybe getting a dictionary and then getting the name that way within utils, having that in common names. and that would help you a lot with consistency. But for the sake of this tutorial, we won't need that. But okay, let's now go ahead and copy all this code. Oh, and sorry, what I should have said here, we're passing this node name through to condition, node name, and then we are going through with the, let me just split this, right split, see if we've got enough space to see everything. So here's our condition. What I did there is I right-clicked on the tab and then went split right. And essentially it gives us a bit more space to look at all of our code. And so we'll see we've got first term, second term, and operation. So what we've got here, we've got the node name. We've got the first term, which is self. The value, which is the second term. Our operation, which is 0, which will then not trigger operation because 0 is the default. So we could also just leave that out. But for clarity and for consistency, we will leave that in for the moment. And what we are then doing is just using output color R. So from our condition node. Because if you see, we're actually just returning the condition node right here. Okay, perfect. Okay, we might have to check that. I think I've just spotted an error, but we'll leave that for the test if it is. Okay, so great. We've got our equality operator set up, which will use a condition node within Maya. And again, see how nice and small the code is for creating all of this, and how much smaller it is even when then we have to write it for functionality in the future. Now let's do a not equal to. So making a condition node and setting the first and second terms in operation. So now we just want to change essentially these items. We're going to highlight, then we're going to press Alt and J. And we are then going to go to the beginning and press Shift and 1 to give us an exclamation mark if your keyboard is English or British. So that's probably different for a different area, but we can go exclamation mark and equals, which is not equal to, essentially just to show what we're kind of doing here. Okay, perfect. I think, yeah, that is what we want to do. Okay, yeah, we're kind of giving a little brief example. We'll actually cut down the code, but we don't want to give so many examples every time. We'll just kind of show and say, well, this is what we're doing. Okay, in this example here. Brilliant. But now the main thing we have to go to straight first away is this one, which is a 1. Okay, because not equal to was the next essentially indexed item within the drop-down list of our node. So if we look here, we've got equal, which is first, not equal, which is second, and then we're following this order within our code. Again, like I said, gives us a nice clear order of how to structure our code, and we're going to copy Maya within our code and just make it Python and nice. Okay, and I believe that is everything as we need to do. And also we need to change obviously this to being not equal. So that it will again denote that this is a condition node, but is using the not equal operator. And you could even do a double underscore here, just to denote that we're using a double, using a dunder method. But I mean, again, it really is up to you on that one. You just have to make sure you remember when we're doing the tests that you've named them differently. But for the minute, keep similar, and then you can refactor later on if you'd like. Okay, great. Let's copy all that code again. Copy it down to our greater than. Okay, perfect. And now all we need to do again is go GT, set that to 2, and everything is set up as it needs to go. Now we're doing greater than or equal to, so we do greater than or equal to, GE, and 3. So a couple more and we are done. Okay, perfect. I think that's everything there. So 4 less than . Perfect. And that should all work as well. And now we have less than or equal to. We'll set that to being 5. Perfect. Okay, I think we have set up all of our code there for the comparison operators as needed. Let me just have a quick look through my notes, see if there's anything else missing. Nope. I think we are good. Okay, so let's have a look. Let's have a quick recap, quick scan over what we've done in this lecture. We haven't changed anything within the init. We are still importing our dep node, dag node, attributes, and attribute. Within our dep node, again, no change. But within our attribute base, what we have changed is essentially we have added condition node name, the equality operators, the comparison operators going all the way down. And we have then created our condition node side. So we have created all the code that we need essentially to use our comparison operators. Let's scroll down to the bottom. And now we've just got a very last item to do, which is essentially set condition. And for this, we are just going to pass the keyworks. And again, we need to import our condition node. And we are going to return condition, open parentheses, we're going to go self.node, because we are assuming here we already essentially have our condition node, but we are now going to set one. And we are going to go then from the condition node, set condition, which again, you can just do set. So set condition, and then add the keyworks. So as we said, this could be set as before to keep consistency, but annoyingly we can't do it within the attribute base unless we do some other changes, because we have already got a set, which is setting a node. So in here, we're kind of assuming a condition node, and then we are saying set condition, because we are actually setting a condition node up. So yeah, and then essentially we're going to be going through the set condition, and we will be passing through the keywords of if true, if false, or return parent, which again is more of a default argument. But more so, the if true is important, because that will be plugged into the if true and if false sections of our arg. So you see we've got the parent and the children of the if true or false. And then those will essentially be decided on by the first and second term parameters in accordance with the type of operation they are doing, which will then output either the parent or the child of our condition node. Okay, perfect. So let's go back, set condition, all working beautifully. And okay, we don't have any serious flags, do we? Or weak warnings. Okay, let's have a little look. Let's have a little look, see what it looks at. Path usually goes with an article. Let's have a little look. No, yeah, we're not going to enact these. These are just essentially a bit pointless at the minute having a go at us. But okay, that is everything for this lecture. In our next lecture, we are going to be looking at the arithmetic operators and calculations, which is again a bit of a heavy one. But that just essentially allows us to use the minus, the plus, the divide, the times, and the power symbols within Python, within our syntax to run commands. And we're going to again hijack those commands within this class to allow us to do Python operations within Maya nodes. So really cool stuff. Okay, amazing work, guys. My voice is held out. I'm going to have another cup of tea. I'm actually going to find a lozenge. I'm going to live a life vicariously. And then I'm going to try and get this one done before I go to bed. So yeah, all good. Everyone's doing amazingly if you followed this far, because this is not easy stuff. We're using a lot of complex methodologies here, and especially when you're very complex when you're kind of abstracting a Maya you're extracting kind of then also computer programming techniques, all both into Python, which is then being set into a slightly complex hierarchy. But if you write all of this code with me, I'm pretty sure you're going to be understanding it all by the time you've written it all out and had to run through it a few times and then gone through the examples with me. It'll make life so much easier for you. But yeah, thank you so much for following along, and I'll see you in the next lecture.